Welcome, ladies and gentlemen, fellow Toastmasters, and distinguished guests. I am a mechanical engineer by study, and I'm looking for a job right now. And one of the areas that mechanical engineers sometimes look in is the area of control systems. Now, how many people here know what a control system is? Alright, that's mattering. Good. How many people have ever had any sort of direct interaction with something that uses a control system, or think they have? I guess they have. Okay. Some people, I'm sure, but that's okay. Pretty much everybody here has come into contact with something that uses a control system since they were probably 2 or maybe 1 or even younger. And in a somewhat philosophical sense, everybody as a human being is an amalgamation of control systems. Now, there are a couple of different types of control systems, but what I'm going to be talking about is the most common one, by far the most common one, which is a closed-loop feedback system. And a closed-loop feedback system is something that takes an input, and I'll explain what these 3 parts of this diagram are, but it basically takes an input and you get an output. And you want to convert this somewhat random input into a desired output. So the 3 parts of this diagram are the plant, which is basically the object that, or the machine that does the action required. So for instance, I'm going to use cruise control on a car as an example. So the plant here would be the engine of the car. The controller is what tells the engine, in this case, how fast to spin. And the sensor basically reads how fast the engine is spinning and also how fast the car is going. So if you're in a car and you want to go 65 miles an hour and you're on this big long stretch of road, you don't really want to have to control, like put your foot on the gas the whole time, you put on the cruise control. And so you're going 65 miles an hour and the road's fairly straight, and then you get to a hill, and what happens? Obviously your car starts to slow down. So the sensor is basically designed to read the difference between the output that you want and the output that you're getting. So in this case, you want to be going 65 miles an hour. The sensor, you start going up this hill and slowing down, and the sensor reads that now you're only going 60 miles an hour. So the sensor sends a signal back to the controller, says, hey controller, we're slowing down, tell the plant to speed up. So the controller does that. The controller sends a signal to the plant, and the engine speeds up, and therefore the car speeds up, and the difference is therefore minimized. So this general idea can be applied to a huge number of applications. So you'll see it in autopilots on aircraft. You'll see it in flush toilets. So when you flush the toilet, the water goes out of that main tank, and then a valve is opened and the water starts coming in. And you know how there's that little rubber ball on the end of an arm? Well, as the water level rises, the rubber ball floats and it turns that arm, which is connected to a valve. And once it gets to a certain spot, that valve shuts, the water stops going in, and it's ready to use again. Now, I said at the beginning of the speech, in a somewhat philosophical sense, everybody has experienced, or everybody is essentially an amalgamation of control systems. So what does that mean? Well, basically, imagine it's really cold out, right? And for whatever reason, you're wearing shorts. And you go outside, and what happens? Your skin temperature sensor, which is basically nerves, says, hey, it's cold out, and it sends a message to the controller, which is your brain, which sends a message to the plant, controlling controlling the actions that would put your clothes on, and says, hey, we need some pants. Clearly mine's broken. But another example is if you get out of bed in the morning and you have a cat or a dog or something like that, and it happens to have curled up next to your bed, and you're about to get out of bed, and the controller's saying, okay, the goal is to get out of bed now, and it's telling the plant, your arms and legs, or the part of your brain that controls your arms and legs, to swing out over the bed and off into the day. But the sensors of your eyes see that your cat has decided to lay down at your feet. And just as you're about to step on your poor little kitty, the sensor sends a message back to the controller and says, oh, don't step there, there's a cat there. And so it tells your legs to go somewhere else. So in that way, everybody has experienced what a control system is. And the reason I like the idea of working with control systems is basically you can take an inanimate object like a locomotive or an airplane or a car and essentially, in some sense, give it life, give it an action not controlled by a human being, and this is how it happens. So hopefully I've shed some light on possibly a somewhat uncommon area of technology, and maybe next time when you flip on the cruise control, you'll have a little bit better of an idea of what's going on. Thank you very much.